Good evening, students. We will start with the dependence of resistance on the temperature. This is a very important topic related to numericals also and the reasoning question also. In case of metals, resistance increases with increase in temperature. Let RT is resistance at T degree Celsius, R0 resistance at 0 degree Celsius, alpha temperature, coefficient of resistance, then RT is equal to R0 1 plus alpha T. Now this alpha has positive value in case of metals. Hence, RT is greater than R0. We also know that RT or R of a metal is ml upon ne square a tau. This means resistance depends on n and tau. For metals, there is no increase of n, but tau is found to change. When temperature is increased, there is increase in number of collisions and hence tau changes. Unit of alpha is degree Celsius inverse. From this result, we can obtain the value of alpha as RT minus R0 upon R0 into T, that is change in resistance, original resistance into temperature change. Similarly, we find increase in resistivity with temperature. Relation is same as case of R. If we plot the graph between temperature and resistivity, we find for copper or metals it follows this type of curve, whereas if we take the example of alloy, say for example nichrome, we obtain a almost straight line graph. So this is for metals. In a note we can keep in mind For semiconductors, the value of resistivity decreases with increase in the temperature. The graph can be plotted as rho versus temperature. It follows this type of curve. So keep this point. In case of semiconductor, there is increase resistivity, decrease with increase in temperature. Second note here is for semiconductors, there is change in N as well as tau in the expression for R equal to ml upon Ne square A tau. So this is the case. Let's have one numerical. Let resistance of a metal is 10 ohm at 40 degrees Celsius and 11 ohm at 60 degrees Celsius. The question says calculate temperature coefficient of resistance, calculate resistance at 0 degree Celsius, calculate resistance at 100 degree Celsius. Now we have the relation RT is equal to R0 1 plus alpha T. We know resistance is 10 ohm at 40 degrees Celsius. So we have equation R40 equals to R0 1 plus 40 alpha, and that is equal to 10 ohm. Similarly, R60 is equal to R0 1 plus 60 alpha, which is equal to 11 ohm according to the question. So if we divide second by 1, we get 11 by 10 equal to 1 plus 60 alpha over 1 plus 40 alpha. Now we can cross multiply. 11 plus 440 alpha is equal to 10 plus 600 alpha. So 1 is equal to 600 alpha minus 440 alpha, which is equal to 160 alpha. So we get the value of alpha equal to 1 upon 160 degrees Celsius inverse. This is the value of temperature coefficient of resistance. If we use equation number 1, we have 10 equal to R0 1 plus 40 into alpha, which is 1 by 160. 10 equals to R0 1 plus 1 by 4, R0 into 5 by 4. So you have R0 10 into 4 by 5, which make 8 ohm. Now for R100, we have R0 1 plus 100 alpha. So this is 8 1 plus 100 into 1 by 160, which is equal to 8. This and this goes 26 by 16, which is equal to 13 ohm. So you can find the value of resistance at 100 degrees Celsius. We have obtained the value of resistance at 0 degree Celsius. So that's the simplest way to solve the question. Also, in the note, we can use a relation for alpha as R2 minus R1 over R1 1 T2 minus T1, where T2 and T1 are temperatures for which resistance is R2 and R1 respectively. Both the formulas work. You may find slight difference in the values, but both are correct and they are given accordingly. That's all.